Here we have a SAT math problem. Okay, let's go to the question. The population of trees in a forest has been decreasing by 6% every 4 years. The population at the beginning of 2015 was estimated to be 14,000. If P represents the population of trees T years after 2015, which of the following equations gives the population of trees over time? Okay, here when we consider the given information and also the answer choices, it's very clear it is an exponential decay. Okay, before we start solving this problem, let's understand some stuff about exponential growth and decay function. That is, we can write exponential growth or decay function as y equals to a times 1 positive or negative r raised to the power of t. Okay, here y is the value of some stuff after the time period t. So usually we take t in years, otherwise according to the information we have to consider the unit for this time period t. And here a is the initial value of the stuff and this r is rate of growth or decay. If it is exponential growth, we have to consider positive sign over here. If it is exponential decay, we have to consider negative sign over here. Okay, when I go over the given information, at the place of y, we have p, which represents the population of trees in the forest. So we can replace this y by p. And a is the initial value of that stuff. That is the number of trees we have initially. So here we have to consider this 2015 as initial time because this information says P represents a population of trees T years after 2015. That is, this T represents the number of years after 2015. So we have to consider 2015 as the initial time. So at the beginning of 2015, the number of trees is estimated to be 14,000. So this is the initial value. That is, this is the initial number of trees. So we can plug in this 14,000 for this A. Let me write it over here. Times 1. And so here the population of trees in a forest has been decreasing. So decreasing means it's exponential decay. So we have to consider a negative sign over here, negative. And this R represents a rate of decay. So here rate of decay is 6%. So we can write the 6% as a decimal. So for that we have to write the 6% as a fraction, that is 6 over 100. When I divide 6 by 100, I'm getting 0.06. So the value of R is 0.06. Okay, now we have to be very careful with this t, and here the unit of t is years. If the number of trees is decreasing by 6% every year, we can write this t as it is. But here it is decreasing by 6% every 4 years. In that case, what we have done is instead of t, we have to write t over 4. Okay, here P equals to 14,000 times 1 negative 0.06 is 0.94. To the power of t over 4. Okay, here I got the equation which gives a population of trees over time, and we find this stuff exactly in answer choice D. The correct answer choice for this question is D.